Hello and welcome to another video. So today is actually a little bit more experiment. It's technically a voice article. It's an auditory article rather than a written one. I'm trying to experiment with this because I want to get this idea out of my head quickly rather than write it down. And I'm a much better orator than I am a writer. So I thought I would do it that sense. So before I start, I want to kind of say, look, here's a new animated background. This is all being recorded live and it's completely unedited, complete experiment. So I've got these new backgrounds. So one of them is this Ginger Bill one. I also have one straight for Odin when I'm talking about Odin specific topics as well. But because this one is not specific to Odin, but it is programming related, I will use the Ginger Bill one because it's just general. So today's topic, as you can probably see in the title, is talking about what I call flash fads. So this is my model, which kind of explains why there are many different trends in programming, and they seem to go, people latch onto them and swap between them very, very quickly. So what do I mean by a flash fad? So a flash fad is a fashionable thing, idea, concept, practice that is in fashion. It's very, very popular at the moment and people just latch onto it. And the flash bit is people latch onto it quickly, and that they latch onto it because they think they're going to get some wisdom or knowledge from it, because they are seeking to find that wisdom and knowledge which they are not finding from other sources. So they may think this new great thing may have the key to what they're solving. So that's the general two things of my model. It seems like a very minor, obvious thing, but it actually explains a lot of the problems that we have in programming at the moment and the programming world in general. So to explain why this kind of happens, and it doesn't really necessarily happen in many other different fields, and it's very obvious once you state it, programming as itself as a field is at the most 70 years old, probably 60 really if you're really pushing it properly. But other fields themselves are thousands of years old, hundreds of years old. So they are old enough now to they've gained their own traditions, and not just gained their own traditions, but they've got in those traditions, those have lasted, that survived, have been shown to work, and they contain knowledge and wisdom from the ages, and that in that regard. But at the moment, with the 70 years, is completely no time in comparison. Something like carpentry is 1,000 years, engineering is 1,000 years, science is hundreds of years. Like modern science is only like 400 years at the most, and but it's still, compared to programming and software engineering in general, if you even want to call it engineering half the time, is very young, and there's none of these traditions. So many of these different things pop up. So first off, we start off with a basic example of what I mean, an example of a flash fad. And one of these was the object-oriented programming craze. So this was it was as it was marketed in the early 90s. So object-oriented programming is a little bit older than the 90s. It started in Alan Kay was the first to coin the word, and he was doing it for his first language, which was Smalltalk. I'm probably getting things wrong. This is all unedited, all live, just an experiment. And he was his idea was mainly focusing on these objects are immutable, they pass the stage wrong. He was trying to simulate the idea of like neurons in a body, in a sense. That's how I was trying to think about it. And he does regret calling object-oriented programming, and I wish it was more emphasis on the messaging in the system, but whatever. Now, what people think of object-oriented programming nowadays is a very hierarchical model. And the way that I personally define it, which I think most people will agree with it even if they like or dislike object-oriented programming, is object-oriented programming is the idea of basing your program around the concept of an object. That's very simple. But what's an object? So an object is a data value. So it's value with associated behavior to it. So nothing complicated there. So it's a value with associated behavior. And these behaviors usually manifest themselves in many languages as such as things like methods, or member functions, you want to call them, or member procedures, whatever, just methods I'll be calling them. Now, one philosophical consequence of this is that values with associated behavior, if you have behavior, it implies an implicit a form of agency to the thing. So it treats as these values have agency, these objects have agency because they have behavior. So like, for instance, an animal has behavior and it'll have a certain amount of agency to it as well. So it gets this sort of thing. If something doesn't have behavior, like a rock, it's not going to have any agency to it, in a sense, in that regard. So that's kind of the general idea of what I mean by object-oriented programming. And you're basing the idea around these objects. It's clear enough. Now, during the 90s, it was very picked up, and it was being treated as if it was a holistic, as in a singular way of solving all of your problems. It was the saviour, the silver bullet to everything. And it was very religious in its settings of how it was actually being advertised to sell it, and that's how it was being sold. And it was being sold like, look, you can reuse components and it'd be easier, so you don't have to write as much code, and it's just easier to manage and all this lot. And they were stating many different things, just stating them, and it was doing all these different things, and that's how it was advertised. It was going to be brilliant. Now, the object-oriented programming in this case is not the same convention as what the person who coined the term, which was Alan Kay, envisioned, but unfortunately, this is how it's been used, and that's how language works, is whatever the common term is that's what people use. So modern object-oriented programming is effectively, the way that I've described before, is a misinterpretation and a naive interpretation of Aristotelian metaphysics applied to a domain it was never actually designed for. So that may be hard to understand if you've not actually read anything about Aristotle before, but the general idea is you're building these different categories of things and hierarchies of things, and you're trying to categorize everything into these artificial hierarchies that you've defined, and trying to associate everything with a behavior and these values and such. Now, there's a few problems here. First, you're just restricting them into artificial categories. Like most things belong to numerous, if not infinite, amount of categories, and you restrict them to certain ones will mean you've got certain issues. Second, these things don't actually have behavior or agency. We're just treating them as if these values. And in fact, values on a computer are just completely like inert. They're not actually like real things. They're just pieces of bits and bytes on a computer. So they're not actually agents. They're not separate from the thing. So they're dumb. They are literally dumb things. They don't have any agency to them. But we're treating them as if that's the case. So there's the problem, is you're trying to produce a model onto something that was never designed for. That's my idea, and that's why there's problems to it. But the thing is even if that wasn't the case, hypothetically speaking, is that the way that we're advertising object-oriented programming is all of these different things. Like, it's going to save you a problem, you're going to have to write your SQ, you write less code, you can reuse it, it's going to make things easier and easier to manage and stuff, yada, yada, yada. And all of these are empirical statements, or they could be empirically tested at least. And every single one of them has been empirically proven to be false. And by proven, I mean that you can show another style, another paradigm, and they'll have a better approach. Because this is the one thing you need to show is, look, hey, if you're going to state something is going to be great, you need hard evidence to state that it is going to be great. And a lot of the time, that's not always going to be the case. And not just it's going to be good, you have to say, okay, it's good compared to what other alternatives. And compared to standard procedural programming, imperative procedural programming, like C style stuff, or semi-C at least, or Pascal, something like that at the time. I'm just thinking that era. It's no better. So that's a very interesting thing to say the least. Then there is, the other thing is okay, if it really did do all those things, but what was the cost of implementing compared to the other style as well? It may have actually had to write 10 times more code, but if it was actually had all the other benefits, then yeah, it may be worth it, but it might not be. It may be if it was 10% more code, yeah, worth it. 10 times more code, which it does turn out to be the case in practice, it's not really worth it. Because there's the different problems. But one, it was being sold like this way because it was a very corporatized thing, And it was being like, hey, this is how you could enterprise people. This is how you could do it. This makes your teams be managed better. You can actually split it off into different subsections, and it's all very modular-like. And it didn't really work out that way. So it's quite interesting that it happened. Now, recently, I would say within the past 10 years, maybe a bit less, people have been starting to realise these problems with object-oriented programming. Even if some people don't, and they're still getting taught all the problems, and they really do in many schools, I've noticed still, and even online, they still teach now these things like, object-oriented programming is the best, it's going to teach you everything. I'm like, right, first off, no. And I'll be very, very clear what I mean. Object-oriented is not the same as objects. So objects do actually naturally arise when you're programming a lot of the time, and you don't need to force them. But again, remember, these are like, we're acting as if they have this behavior and agency, even though it doesn't exist, but they do naturally kind of arise, things with values with a kind of a semi-pseudo behavior to them. Object-oriented is saying is everything has to be an object, or everything has to be designed around this. And again, so I was saying in the past 10 years, these different things have been arising. And people explaining, yes, it's bad. But many of the same people who were latched onto the thing and said, okay, this is bad, but therefore we now need to go to our new Lord and Saviour, which is functional programming. This will help all Saviour our problems. And it's like, all you've done is, and as I call this, it's kind of a flash fad. You've swapped quickly one fad for another one. And you haven't really understood why your previous one was wrong, and understand the logic. You could apply the same logic to the reason why to the thing you were just about to pick up. And yes, these ideas like functional programming does have a few cool things about it, and a few interesting things from a technical standpoint and a mathematical standpoint. But the problem is that actually useful? Now, for me, I recently wrote an article on my website, which was I called Pragmatism in Programming. And this was me pretty much explaining my school of thought in programming, actually. And again, people have different philosophies in programming, and actually they may not realise that they are usually part of different, maybe informal, but schools of thought. And in this style on my website, I was trying to do in a different style. So again, similar to what I'm speaking out now, this style I wanted to have in like a proverb style rather than a very prose style. So I was kind of splitting them out. So to me, the concept of programming, just to quote myself, programming is a tool to solve problems that you have in the domain of computers. And the other quote proverb I said is that the purpose of a program is, and ought to be, something that transforms data into other forms of data. And again, I'm just going to say the first another two ones, that to try to solve the specific problem you have, not a general problem you might have. And programming languages, compilers, libraries, etc. are just tools. They are not worldviews nor signals of social status. So that's kind of the general idea of what I think programming is about. So when I'm trying to apply this to these different ideas, like for instance, okay, we know object-oriented programming is bad and it doesn't live up to the claims it was going and how it's being advertised. Okay, great. But why should we go to this other paradigm? And you do have to ask these questions, like functional programming. For many domains, it may be perfectly valid. And it's a tool, you have to remember, functional programming, not orientating around functional programming, but functional programming in general does have many different uses. You can use it to actually have like programs which are kind of like mathematically proven. They're very useful in that regards. They're very good for explaining mathematical things in general. But the question is, for the problems you're trying to solve, has it been proven that these are actually decent to write in? Because unfortunately, most functional languages, not all, but most of them, are usually designed around like lambda calculus or a very Lisp-like thing. And that doesn't necessarily map very well to modern computers. While something like C, like a very imperative style, will map pretty well to modern computers. So there's a better way, even though that's not functional, it's very mutable, there's very separations between expressions and statements and declarations, while in functional it's all usually, most functional languages, I'm not being very general here, are quite broad. And the thing is that loads of programs, I could do very well in the normal basic procedural sense and style, and they get along very well. And that's a very interesting question as to why. For me, when I was writing, the reason why I wrote Odin, this was nearly 4 years ago now. Odin is nearly 4 years old, by the way. Congratulations to Odin. It'll be 4 years next month in July of 2020. Yes, I started it in July or June, one or the other. It's around by that date. There's not really an official date. It's just the first commit in on GitHub is in July. And I was designing it. I was creating a language because I wanted an alternative to C. But one of the things I noticed in one of my very early videos, if you find on this channel, is that C is pretty damn good. It's kind of hit a middle, like a very high local maxima with regards to productivity and what you can do in it. And it's because it kind of gets a few things right. And people take a lot of these for granted now because they're in every language, and also because it seems obvious, but it wasn't obvious at the day when it was being created. And these ideas have kind of proven themselves. These are the wisdom we need to search out and look for. We have to look for this wisdom, these virtuous ideas, in other things and in people and other tools, and we need to ask those peoples what kind of those ideas they can have about those wisdom, that virtue, because you cannot teach it to others. So this is one of the things, and that's kind of very Aristotelian look at things, I know that, but you can look at C. Now C has got very distinct things. It has declarations, statements, and expressions, and they're all very well separated for the most part. And if you look at it, it's quite easy to look at. You've got the declarations, which you're declaring these entities. So these declarations are very separate things. They are entities with names. They're like names. Like, okay, so we're going to declare a variable with a certain name and a certain type. We're going to declare a function or procedure, whatever you want to call the word, don't really make a difference, with a certain signature. We're going to declare this type. We're going to declare this constant, and you got yada, yada, yada. So we have these different categories of declarations and entities in the thing. Entities are named declarations. That's the word I usually use, and it's the word I use in compiler talk. We also have the concept of statements. So statements like if statements, while statements, for statements, do while statements, switch statements. Is that if else, well, yeah. And some other ones as well, but in general, yeah, go-to statements in C, but I'll ignore that one for the time being. I'll explain why. But these general ones, you can pretty much do any programming, and these are just general constructs that we have. So we have branching statements, and we have branching statements and looping statements are pretty much the general ones. And we have conditional statements, conditional, branching, and looping. So conditional is an if, branching is like a break or continue, and then we have looping ones, which is like a for loop or a while loop. These are different things, and we structure the program in these statements. And then we have expressions, which are very simple, like for instance 1 plus 2. So we have addition, binary operators, unary operators, index operators, call expressions, etc. So we have all these different concepts in the different language, and they're broke down. Now we build these together, and that's pretty much how it works. That is how we people work. That's how well the computers kind of function at the end of the day, and you can map that pretty well. And it's kind of interesting that the C got there pretty interestingly, like there very quickly. And I also agree with like Fred Brooks in this regards that I don't think there'll be another order of magnitude in language design, like 10 times better than C. You probably get 2 times better, maybe. Productivity, but you won't get 10 times more productive with it like a textual language. And it's because it's settled on how people think about programs, how to solve about problems, and how to reason about them. At the end of the day, a program is an algorithm. It's just something that transforms data into data, and you want to express that algorithm in a very simple way. You can express it in a very mathematical sense, like a pure mathematical function, or you can express it in how you'd actually bake a cake, or brew beer or something. Like you got recipe to it, and that recipe, you can follow instructions, and if you get to a certain condition, you do X. If you do this case, it's like that, or do another way in another case, and you've got these different branches, and it's not very mathematical. It's very, very structured and ordered. So if this, then that, else this, do that. Very nice and ordered. And C got on that very well. Now, one thing else it did is he's got structured programming as well, which is what everyone takes for granted nowadays, is structured programming, which is like blocks or structuring code that we don't have to use GoTo anywhere. Like in assembly code, you would have to jump to a block, like a named block of code, which is pretty much just like, hey, jump to this bit in the machine code, which is at this offset, like at this memory address. But we just give it a name. And that's very unstructured. But as soon as we had structured programming, it made things better. So one of the things I did for the Odin programming language is I was trying to experiment more in the structured area, because I knew, look, if we had more structured things, from my experience, it would actually make things better. So one of the problems is GoTo in C is unstructured. So they are valid use cases for GoTo, but most of them I could actually replicate with different structured constructs. So one of them is the defer statement, which in Odin is a defer statement to the end of the scope. So first scope is structured concept, but yeah, it's the thing, because you do many operations, like you open a file, check to see if there was any errors, and then if there wasn't, we defer the closing of the file to the end of the scope. Very, very useful. Done. Then there other structured ones is, for instance, naming a loop or an if statement or a block, and then branching out, breaking out of it, or continuing out of it for that particular block. Because one of the issues or main advantages many people use GoTo again. So the first one was to defer. GoTo, that was for cleaning up. The other one here is to break out of like a nested loop or a nested switch statement or something like that. And you want to just label it. So a common thing in C, you'd use GoTo for. But if you're trying to be explicit, you're trying to show the semantics and the structure, and it's like, no, I'm breaking out of this particular block, this particular data structure, this statement, control flow. That's what you want to do, showing the intent. And that's a much better way in structuring, because then you can read from top to the bottom, see what's going on. And then the third thing in Odin that I added was the ability to have nested procedures. So I think that you can probably replicate with these three things. Nested procedures is like a procedure you can just literally nest in another procedure. Coupled with, which is not a closure, by the way. Closures, you capture the parent scope, variable scope of the procedure. This one doesn't, but don't need it. But for this case, coupled with the defer and coupled with named like control structures, you do not need GoTo for anything else. I think I can prove that, because it's technically you can represent the same DAG, the directed acyclic graph, using those constructs, and therefore if you can replicate the same graph, you've got the same thing. So that's my idea. I think that the adding like things like defer would actually clean things up as well. And also the other thing I added as well, I just remembered, to definitely make it a lot clearer, is the ability to name return values. So you can have, and these named return values act as if they are variables in the language. So that simplifies a bunch of things. So that's that for the most part. So why did I bring this up? We're into 23 minutes into the video, audio article, and I'm trying to explain like what's going on. But yeah, I'm trying to show that there are some wisdom that we can look to different things to show that what has worked. Things that we take for granted already in the game, like in programming, even though they seem to have so much utility from them, we can look at some of the wisdom that has been carried there, and we can look at that. We're often looking at these fads. Now, in like a reality thing, we would love to actually just go to what the general culture is, which is traditionally what you do. But unfortunately, at the moment, we need to find this. Now, I'm not saying that everybody can find this, nor they should. I'm just trying to say that you need to think, if you're using a tool, you want to use the best tool you can, if you can get it and you want it, and understand why it works the way it does, and what utility you can get from it. So you're just trying to work within the domain that you have and trying to get the best that you can. And also remember, like, you can probably get the best you can with the certain constraints and scarcity, like, of decisions that you do as well, because you can get a lot out of certain thing, but it'll take you a long time to do it, or it takes you a lot of money, or it takes you a lot of sanity, whatever the constraint is. So that's kind of what I'm trying to state as. But it's this idea that people do love to jump between these different fads because they are looking for that wisdom. People do want to look to the crowd for knowledge. It is very natural for it to be, and it's very rational. So this is an extra aspect of this thing. This model assumes people's rational because they are in this most cases. Because they don't know what the best way to do, it is perfectly rational to look to the crowd what to do. Because statistically in many things, there is usually wisdom in the crowd, and the crowd usually knows what they're doing. But in this case, unfortunately, they don't. They don't know what they're doing. And it is a very interesting thing to look at human psychology this way, and I'm just trying to think of a way of phrasing it, but it's people are acting rational when they do this, even though it's not the best way of doing things, because for them they want to get the information quickly, the knowledge, the wisdom quickly. They don't have to spend months, maybe even years, honing their skill to figure out what the best thing is, when they can just tap into that cultural background knowledge in society or the culture of programming, and it's already there. And the problem is, it isn't already there yet. We're nowhere near there yet. Programming is still, we've probably just invented the wheel, maybe, or a form of wheel for one particular purpose. We're not there yet. It's like, this is one thing, I'm going on a little rant now anyway, but I am found that when I hate the people who phrase that, hey, this person's got the not invented here syndrome yet, or they're just reinventing the wheel. I'm like, how many wheels have you actually seen in real life? And none of them are virtually the same. That's because different wheels are used for different purposes. Like, I'm not going to use a bicycle wheel on my car. My car weighs over a ton. My bicycle with me on it, maximum 80, 90 kilograms, to use kilograms for people, because then it's more universal. It's not that much. So clearly there are different types of wheels for different purposes. So reinventing the wheel is a really bad analogy, but it's also a better one. I don't know. It's just one of those things where I've been thinking about it and stuff, and sometimes I don't mind. Some people say, "Why you just use a library to solve the problem you've got?" Someone else probably already solved it. And the thing is, my personal experience, a lot of the time, yes, there's a library out there that solves a general problem, but I've got a very specific problem. And when I try and use that library, it's very useless, and it's like they're trying to solve a different problem that I didn't have. So therefore, I've now either got to modify that library slightly to solve the problem I have, so it's not just ready used, or I have to write it myself again, just to solve the problem that I have, because someone else may not have had the problem I have. So you've got all this battling to do with the different problems. And again, it's a horrible thing to have to go through, because you don't know. And again, sorry, I don't want to rant for this, but yeah, it's for beginners. Yeah, they probably reinvented the wheel, but it's like, for beginners, they probably should reinvent the wheel in that sense. I hate the term, but you know what I mean. They should, to understand how things work, because you need a better way of thinking. Because then if you get your way in a better way of understanding how things work and you go through that process, you'll get a better skill, and you'll train your skill of programming better. You'll understand how things work better, algorithms work, compilers work, computers work in a better way. So that's the general idea. So this is kind of what my ideas of this flash fad model is. And it also explains a hell of a lot of what the problems we have in programming at the moment is as well. Because one thing is, if there is no cultural norms or traditions or customs in general in the background to prevent the bad things happening, those bad things will happen. This is why I honestly say things like the web are broken. So the World Wide Web is a bunch of crap. And I know this sounds like I'm just going to stop for a second, but I'm just going on a little rant here. Trust me, they're all a bit related, but I think the World Wide Web is mostly crap. Its foundations are awful. Talking about the original web, HTTP, the protocol, textual based, bit crap. Like, it's not great. Text based is, I know in some means more extensible, but like binary formats are quicker and everything. Text is a lot harder to parse and slower as well, and you may have to actually encode more data in the text when binary is smaller. So it's fine. HTTP is not great. TCP and UDP are fine. They are older than the World Wide Web. They're still part of the internet, but they're old and they're okay. HTML is a very weird thing. Its layout is very bug prone. Like, even though it's actually HTML, which is very different to like a strict XML or SGML at the time it was designed, is very bit more lenient. And it's like, why? It's like, if you wanted to reduce the amount of typos that people could have done, or the issues that people have done in their programming, they should have designed the language to be better to do that, rather than just trying to jerry-rig it to get it in there. So that's the second thing. The second thing is JavaScript, which again, it was made by pages more dynamic. JavaScript is a very poorly designed language. I understand it because they pretty much designed it in a week. Designed, not implemented, but designed in a week. And it's got a lot of the flaws in there. Originally, it was meant to be a scheme language. And then they said, nope, we need to make it look like Java. Like, Java's all the range of them. Look, Flash Fad's popping back up again. Java's all the range. We need to get on that bandwagon, make it look like Java syntax, make it look like that done. So that's why, like, JavaScript, when you use it, is very scheme-like, kind of, in fact. But like a Java-like syntax. It was originally, I think JavaScript was called Mocha, and then they called it JavaScript just to get on the Java bandwagon. Again, seriously, it was that popular. Because object-oriented programming, man, everything's an object. It must be amazing for enterprise things. Claims didn't work out. Yeah, there's your problem. And then there's CSS. Now, CSS is another big one. So what I mean by this is that CSS, the idea of separating HTML and CSS and JavaScript, is that you're meant to separate, presentation from the content. Now, if you asked a graphic designer, again, graphic design, been going on for 500 years, probably more, probably a lot more. If you ask a graphic designer, yes, the concept of separating presentation and design, they'll look at you in bewilderment. They'll be going, but presentation is content? Like, separating presentation and content makes no sense. Presentation is content. And that's the problem when they have in the web. I understand the general idea that they were trying to go for. They were trying to say, look, you can put your content in the thing. You put any style sheet you want, because they are originally in the web. You could swap your style sheets all the time. And most web browsers are trying to make it dead easy. So you could swap a style sheet for a website for accessibility reasons, or whatever the reason is. Because the content was more important, the styling, the presentation. So you could just change it. This is engineers. And I'll call them arrogant, hubristic engineers, because they thought they knew better than what graphic designers, and they never even bothered to ask a graphic designer or a typologist or any of this. A typographer, I don't know the technical term is for that thing person. Any of that. And it's like, why? Like, it does annoy me for the most part. But I digress. And the web has built on top of this. So we have people now, we're trying to add more stuff on top of the web, and many things popping up. And many of these different fads are popping up. For instance, there's a lot of JavaScript frameworks that popped up in the past 10 years. The first one, one of the first ones being like jQuery, and people are just saying, look, we need to try to solve the problems with JavaScript and trying to make things simpler. And then people just popping on to the next framework because they think this is going to save their problems with the silver bullet again. And again, there is no silver bullet. And we just keep going through, and it just keeps going and going and going. These people keep, and I understand it is actually perfectly rational, but there is no evidence for any of these claims. No evidence that these are the best practices. And people in general, which is not really any fault of themselves, because they assume that the crowd is clearly, because everyone else is doing it, they must have thought it through, which is again rational to think. But we have no hard evidence to show that these are good approaches to things. We are not comparing them to other approaches, saying, yes, this is better than this approach because of X, Y, and Z. We're not comparing and then we're not comparing the costs to it. Like, okay, this approach is technically better in the long run, but it takes more money, or takes more energy, or takes more memory, or takes more sanity, or performance, or monetary issues, or speed, or just things like that. And it depends on what you're trying to optimize for. And this is where people need to, I honestly, for yourself, think this through in your programming life. How and what wisdom am I carrying? Pseudo wisdom, I should say, that I'm carrying around. And should I just question everything that you think is true and ask yourself, what evidence that this actually supports the claims it supposes it tries to solve? Be it object-oriented, be it functional, even be imperative, be any kind of paradigm, any I wouldn't call this a school of thought, but yeah, paradigm is the best, like certain ways of programming, and that has to be the only way of doing it, or it's the best way for this domain, or whatever. Question that. Now, if it turns out that yes, this is actually the best thing for the problem, brilliant. Now understand why it's the best thing for the problem. Now, this is just from a personal level. I'm not trying to say everybody should try and do this, and because I think that's just irrational. That's just irrational, because humans are humans. But I'm just trying to say that you should try and understand why you are productive with the certain tools that you have. Try and look for the good aspects of your tools, because again, programming is just tools, libraries are just tools, whatever. And understand why those are the case, and try and look for the wisdom in those bits. Don't assume there is wisdom in a practice or a fad or any fashionable thing or a practice. Look for it and ask questions about it. Asking questions about why it thinks it's got wisdom, assuming it's like anthropomorphizing something, or even the people using it, ask him why they think it's got wisdom in it, and ask them for their ideas of wisdom. So I'm going to end it here now. Thank you for me rambling. I've been rambling on this topic for the last 38 minutes. Again, it's a bit of an experiment to see how things go. I hope people enjoyed that, and if you want more similar things like this, please tell me. If not, please tell me. If you prefer me writing this stuff down rather than speaking it, that would be lovely to know. So thank you all for watching, and, well, mostly listening, in fact, and good night.